Hello everyone, welcome to the course on artificial intelligence in industrial and management engineering. We have covered various topics from learning in AI systems to what are the different kinds of learnings like inductive learning, deductive learning. Then we have started talking about what are the different kinds of machine learning systems. Today we will start by introducing what are the classification machine learning systems, supervised machine learning systems, and supervised reinforcement, what is reinforcement learning, what is unsupervised learning, and finally we will try to discuss a roadmap of machine learning systems. So, in the subcategorization of supervised learning, we will start with classification. So, the goal of these kinds of systems is predict the class of new data points based on historical data. So, this is nothing but saying that you have what we have previously discussed, that let us say you have 1000 images of cats and dogs, and for the 1001th images you need to your system should identify whether it is a cat or a dog. Okay. So, the historical data here is 1000 images, and the class of these images could be a dog or a cat. Okay. So, class labels are discrete here. We have already talked about what are discrete values. So, they can be unordered values. So, an example could be email spam detection or sentiment analysis in unstructured text. Okay. So, this email spam detection is a classical spam / ham system, where two classes that we need to identify is whether an email that you have just received is a spam or a ham, means a normal email. Ham is just a normal email. So, classification can be binary or multi-class. Few examples of these systems could be handwriting recognition, which is a multi-class problem. Now, for creating these systems, let us say modeling A to Z handwriting can provide good results for identifying a newly written character. Okay. But if we use this model to identify numbers. So we have developed a system for identifying the handwriting for A to Z characters, right? But if we are applying this model to identify numbers, then it will fail. Okay, why? Because the model is based on training data set. So what we are trying to say here is, whatever the historical data that the model has used to develop a particular machine learning system, you can only predict the same class of outputs that the system has just seen. So if you are trying to predict the numbers from 1 to 10 by utilizing a model or which has seen the classes of handwriting for character A, B, C to Z, then it will not work. So that is why whatever the input you are giving and the quality of that input gives you the quality of your output. So garbage in, garbage out systems are these are that kind of systems. Next is regressions. So here the goal is the response variable or the output variable is continuous. Okay, so the goal is to predict the output using explanatory variables. So we have just introduced a new term here. What are explanatory variables, right? So in our machine learning terminologies, we utilize different kinds of terms for specifying same thing. So we will try to cover different kinds of terminologies in our next slides, but here I want to just tell you that an explanatory variable is nothing but the features in your input data. So if you are working on a problem to identify the weight of a person by utilizing its different characteristics like height, color or 3 or more features, then all those features that are being used to identify the weight of that person, those are called the features of the input data, and they are also known as explanatory variables. Okay. So predictor or explanatory variables are also known as features. Response variable or output variable is also known as target. Okay. So here we try to fit a line on the available data to get prediction capability for new data points. So we all know about the basic equation of line, that is y is equal to mx plus c. Okay. So let's say here the output is y, the input is x. So the y is the target variable, x are your features. So let's say you have five features. So, you will have x1, x2, x3, x4 and x5, and for each combination of these x's you have a y variable, right. So, if let us say we have 10 rows for these kind of data set, okay. So, now by utilizing all of these x's you can find a y, right. Now, if we have all the y's for these 10 rows, then by developing a machine learning system for this system, we can say that for the 11th row, without knowing y, my model should give me the y, the value of the target variable based on my features, the values of x, right. So, as a simple example, regression is nothing but, let us say you have a single x and you have a single y. So, for each x you have a y, okay. So, let us just randomly point out few historical data here. So, every scatter point in this chart is combination of my features and my target variable. So, if I just create line here, so this line is something that my system has learned by seeing these data points, right, all these data points. So, this is the best fit line on this data, where the distance from this line to each data point is minimized. So, we will learn how to create these kinds of system. Now, after learning this line, what we have got. So, if you have a new data point, let us say somewhere here xi, let us say, and you want to know what will be the value of y for this xi. So, you can easily plot this line by extending it, and you can see this is the value of y, right. So, that is how you will try to predict new cases, new input data and output data. That is how you will try to predict new output data by getting new input to the system, right. So, this is how regression works. Next is a different kind of learning technique, that is known as reinforcement learning, and here the goal is system development that can improve its performance based on interaction with the environment. So, these kind of systems are much more feels like agents that are working on their own, right. So, what we are doing here is we try to develop systems that improve their own performance. How? By interacting with the environment. So, they take inputs from their environments, try to develop new systems, new links, and try to understand what is good for a system to perform well. Okay. So, performance improvement comes with a reward or feedback signals to the agent in the system. So, whatever the agent is doing inside the system, it will either get a reward or not. Now, the more the agent gets rewarded, the more it will perform similar kinds of things to attain its goal, that is to increase the performance of the system and to get the pre-specified goal of the system. Okay. So, these kind of systems are related to supervised learning. Why they are related to supervised learning? Because of the reward system implementation. So, these rewards are nothing but some kind of labels that says that if your system is getting these labels right, and when they are getting rewarded, they are trying to perform good in the overall system to attain their pre-specified goal. So, agent conduct exploratory trial error sequences to maximize this reward. Now, chess is an example of reinforcement learning systems. So, revisiting again supervised learning, we know the right target variable, but in reinforcement learning we detail the reward measurement to develop trial error capability and maximize the reward as outcome. Next, let us understand what is unsupervised learning. So, here the goal is to extract meaningful information from the data set where no labels or rewards are available. Okay. So, this is nothing but a general pattern discovery technique, right? And here we organize data into meaningful subgroups without any prior information. So, these are very general systems where we do not specify or provide any target variable to the system, and the system tries to learn the target variables and try to divide the complete input data based on the learned responses. So, these kind of systems facilitate identifying customer segments to deliver customer centric experiences. Okay. So a basic example could be an e-commerce website being used by different categories of people. Some are students in a university or a school. Some are already working as an employee in different kinds of organizations. Now, all of these kind of customers are using a particular e-commerce website, and when they are using, they usually have a pattern of buying things. So a student will try to buy stationery frequently, books, right? But whereas an employee will try to buy household essentials. So by just giving the data to a particular unsupervised learning system, the machine learning algorithms will try to identify these segments in the input data and will try to create different kinds of classes for these identified different classes, right? And without specifying any kind of customer segments by the developer of these systems. So that is how unsupervised learning systems works. Some examples could be k-means algorithm or hierarchical unsupervised learning systems or principal component analysis systems or at autoencoders. Okay. Now, specific unsupervised learning algorithm could be dimensionality reduction. So, this is a subfield of unsupervised learning systems. What they do is they reduces the dimensionality while retaining the information from the data. Now they are useful in feature processing to reduce noise from the input data. Okay. And they can also be useful for visualizing high dimensional data by projecting it onto 1, 2 or 3 dimensions. Okay. So we have already seen one example, like I have stated earlier, that let's say we have a problem where the input features could be x1, x2, x3, x4 or x5 and the target variable is y, right? Now usually when we have large amount of data sets and the problem could include very large amounts of input features. So this x5 could be x50, x500, right? So how to evaluate these kinds of input features so that we can get y easily? So in these kinds of problems where the number of features are very high, we usually try to either visualize high dimensional data, then we can use dimensionality reduction techniques, or we can use to ease our feature processing so that we can reduce the noise from the data. So, these kinds of problems can utilize dimensionality reduction techniques like principal component analysis. PSA is an example of dimensionality reduction technique. So, we will try to discuss the detailed roadmap for a machine learning system in the next class. Thank you.